everyone, this video today is going to be about sketching periodic functions. So first of all, when we're sketching these functions, we're going to be looking at them in this general form where it's y equals a sine of bx plus d, or y equals a cos of bx plus d. Now, just as a bit of a recap, the a is the vertical dilation factor, sorry. That means it changes the amplitude. It stretches the function up or squishes it down. Remember that the amplitude is the height of the function measured from the midline. So if we have our periodic functions and you've got your midline running through the center, the amplitude is measured from the midline up or measured from the midline down. For periodic functions, because they're symmetrical around the midline, the amplitude can be measured either way and it's exactly the same. Now the B is the horizontal dilation factor. It stretches the function out from side to side. So it means that you can have a function that's really, really wide. It takes a long time to repeat a cycle, or it can be a function that's very, very skinny. You can get through a cycle very, very quickly. Now, the dilation factor, because it stretches the function out from side to side, that actually affects the period of the function. Now, the period of the function is the time or the length it takes to repeat one cycle of the function. So one period is one cycle of the function. D is the vertical translation factor. So that means that it moves the function up or down. Okay? So once you know these 3 key points, or 4 key points if you include the period, all you have to be able to do is recognize them in a function, and then you can sketch over a given domain. So let's just see an example where y equals 2 sine of 4x plus 3 over the domain 0 to pi. Okay, so first of all, A is the value in front, the coefficient at the beginning. Okay, so in this case it's 2, so that means our amplitude is going to be 2 units high. B is the value next to the x. Whatever number is next to x, that's your B value. So in this case it's going to be 4, nice and easy. Now that allows us to find the period. The period is 2 pi on B, so we have 2 pi over 4, so the period equals pi on 2. So that's really important. That means we can draw one wave in pi on 2 units. Okay, now that's going to be really important for us because I know that my domain that I have to sketch the function over is from 0 to pi. So because we have the period of 2 pi, that means I'm going to have to draw 2 waves, 2 full cycles, because 2 lots of pi on 2 fit into pi. That's very important to consider. Now D in our function, D is the number all on its own. At the end, it's the number that picks up the function and moves it up or down. The vertical translation factor, so in this case it's 3. Okay, so we've got all our important points. Now to sketch. The first thing I always draw are my axes. Okay, x and y axes, x on the bottom and y up the side. Okay, now the next thing I always draw is my dilation, my vertical translation factor. I mark on D. So D in this case, let's do it in yellow. D is 3, so 1, 2, 3. D is here at 3. Now, I also always like to put in a little dashed line for my midline, so I've got something to work around. That means the function is going to be symmetrical around this middle line. Now, we have to find the max and min for the function. The max and min, we're going to use the a value, or the amplitude, because I know the height of my function is going to be 2 units high. So the a value can give me my max. My max is here at 2 units because it's d plus a at 5. And then my min value is at d minus a, which is 1. And that means my function is going to be 2 units up from the midline and 2 units down from the midline. Notice that I like to draw the lines in for those points as well. Just gives me something to work across. The last thing I draw in is the values along the x-axis. Now we're working in a domain that's over pi. I know that I have my period is 2 pi, so that's half of that. So I can see straight away that I'm going to have to draw 2 waves. Now whenever we're drawing periodic functions, there are 4 key points. So I need to split each period up into quarters. So I just mark them off. It's not really necessary all of the time to mark in these values at the bottom. Sometimes it is, sometimes it isn't. We could see that if one cycle is pi on 2, that means half of that is going to be pi on 4, and these guys are going to be pi on 8 each. Okay, really not necessarily at this point to be able to draw it in. You can do that if you want though. Okay. So we've drawn in all the key points, we've labelled our graph really well, made it really clear. If I was drawing a cos wave, I would have drawn it exactly the same way. It's no different. The only difference that would be between a cos wave is what I'm about to do now. So sine waves, all sine waves, no matter how big or how squished or how fat or how wide they are, all sine waves start in the middle and then go up to the max, come back to the middle, go down to the min, come back to the middle. Every sine wave will do that. So it'll always go middle to the max, middle to the min, and then back to the middle. Middle, max, middle, min, middle. Okay, so our sine wave. I am going to start in the middle. So that's where I start here. Okay, starting at 0. Now for every one of these quarters, I make an important step in my sine wave. So middle, max, middle, min, middle. Now I start my second wave. Middle, max, middle, min, middle. And then all you have to do is join the dots up. Okay, remember it's a periodic function, it's a wave function. It needs to be a smooth curve, no points at the top. Okay, so there you are, 2 sine of 4x plus 3, that's what that looks like. Okay, one more example. I thought we'd do one with a slightly different period. So let's have a look. Y equals negative 3 cos of pi on 4 x plus 5 with the domain from 0 to 8. Okay, so let's write down all our important key factors again. Amplitude, horizontal dilation factor, vertical translation factor. So A equals negative 3. Just like any function, the negative is telling me that my function is going to be flipped over. It doesn't change the size. The amplitude is still 3. 3 up, 3 down. B is pi on 4. The number next to x is always my b value. So therefore, the period is going to be 2 pi divided by b, 2 pi divided by pi on 4. Remember, when we're dividing fractions, we multiply and flip. The pi's cancel out and we're left with a period of 8. Now let's have a look at our domain. My domain
is from 0 to 8. So one wave is 8 units long. My domain is 8 units long, so I'm only going to have to draw one wave in this case. D is 5, so that means my midline is going to be 5 up. So, axes, units, ooh, just fit it. Okay, midline is at 5. 1, 2, 3, 4, 5. Drawing my midline. Amplitude is 3, so I go up 3. 1, 2, 3. That gives me my max. Amplitude is 3, so I go down 3. Mark on my length of my period, the length of my wave. Divide that up into 4, into quarters. Now we're ready to sketch. Now this is a negative cos wave. Cos waves, when we have a nice basic cos wave, always start at the max, go to the middle, go to the min, go back to the middle, and finally finish back up at the max. With a negative wave, it's flipped over. So we're going to go min, middle, max, middle, min. If it was a positive cos wave, that would be opposite. We would do max, middle, min, middle, max. But because it's negative, it's flipped over. So let's mark in our key points. Minimum, middle, maximum, middle, minimum. Then we join, oopsie daisy, join up the curve. That was a bit hard drawing on this tablet. So there we go. That's a bit better. So negative 3 cos pi on 4x plus 5. Okay, I hope that helped. Let me know if you need anything else. There'll be some more videos coming soon with sketching some more complex functions and also finding the equation of a periodic function if you have the graph. Okay, see you soon.